Don't ever let people tell you you can't do something. When I designed this aircraft, it was on the back of a napkin back in 1991. And it looks very similar to what you see today. If you have a great idea, get people around you, explore that idea, begin to build a prototype, and then begin to work your prototype, and then talk about your invention to others so that you can bring it to actual fruition and produce something. When you think about the unmanned systems business, it's not just the aerial flight of a drone, it's the kinds of technologies that one wants to become involved in so they're most effective in careers with this kind of aircraft. If you look at the entire airframe, this is a 3D printed airframe. So we use 3D printers to print the entire airframe as a complete fuselage and airframe. In fact, when we 3D print it, it's printed vertically. So it starts at the bottom with the printer, just like a piece of paper, and it starts printing all the way up until it gets to the nose. And then there's individual parts that get printed separately. So this particular ducted tilt rotor in the back is printed separately. We have the canopy that's printed separately. There is a belly hatch on the back that is also printed separately. And so 3D printing is really a next step in technology for not just aircraft, but for a number of different industries. You'll see 3D printing in medical, where they're beginning to 3D print particular components of the body, bones, for example. There's some lungs being tested for 3D printing materials. So you can have hard materials that are printed, but also flexible and soft materials that are printed. So I think that's one area of concentration. The other area is communications. So when we're flying this drone, there's a number of ways that someone with a handheld radio can use line of sight to see the drone flying. That's a radio communications technology. Just so happens we're working with Georgia Tech Research Institute to make our canopy a smart canopy, which will have about 7 different radio frequencies that are built into a 3D printed canopy. So that canopy is very lightweight compared to the other kinds of components we would have to buy, and doesn't take as much power. So that smart canopy will be good for line of sight, control of the drone, but also beyond line of sight, looking at controlling it via satellite. We also can control the drone based on cellular communications. So that's another technology whereby, just like your cell phone that connects to a cell tower, we'll be able to control these through cell towers and smartphones. If you look at our micro aerial vehicle, it's only 7 inches versus 2.4 feet. That one will have a Google Glass interface with a little heads-up display. So it'll carry a camera in the nose of the drone. So the operator will be able to see what the drone sees in the heads-up display, and then we're going to be using voice navigation to actually direct the drone as to where to go. Another technology is Intel's RealSense for drones, which is collision avoidance. Collision avoidance will have 2 cameras mounted on the wings. Those will be the eyes of the collision avoidance system. So think about a forest, to be able to fly through a forest. Those cameras paint the imagery of what's in front of the drone, and for near objects, the drone will know to avoid those particular objects and continuing flying from point A to point B. So when I look at this technology, it's really a combination of several different technologies all coming together that make this aircraft a valuable asset as a customer or an individual who wants to fly. So for the Future Development Youth Center, this is a shout out. You guys are doing a great job. Don't stop now. I'm looking forward to your success.